Let us see about block diagram representation. After completion of this topic, the students can able to analyze the spectrum characteristics of signals using the Fourier analysis, and also they can classify the system based upon the properties and determine the response of LTI. Similarly, they can identify the system properties based on impulse response and Fourier analysis and apply transform techniques to analyze continuous block diagram representation. It is a structural representation using interconnected basic building blocks and is the first step in hardware or software implementation of an LTI system. Here the first one is this is the adder. Here we are giving if you want to add two signals, we are giving the two signals to the summer and we are producing the output as y of n. Next one is the multiplier. Here in this multiplier the input signal is multiplied with the scaling factor and finally we are getting the output as y of n. And again next one is the unit delay element. In this unit delay element we are giving the input signal to the delay function z power minus 1 and we are getting the output as y of n. And pick of node, here in this pick of node we are adding two, there is two multiplication of this two nodes that is joined together and we are getting the output as x of n. And here in the case of block diagram representation there are four types of system realization in continuous time invariant systems, and they are the discrete time direct form 1 realization, direct form 2 realization, cascade form realization, parallel form realization. Direct form 1 realization, it is the direct implementation of differential equation or transfer function describing the systems, and it uses separate integrators for input and output variables, and it provides direct relationship between the time domain and s domain equation. And in general this forms requires 2n delay element, that is it includes both the input and output signal and for a filter of order n, and this form is practical for small filters. And some of the advantages of this direct form 1 are it is simplicity and more straightforward realization, and some of the disadvantages are more number of integrators are used and insufficient and impractical for complex design. And the transfer function h of z of the IR system is divided into two parts connected in cascade, with the first part h1 of z containing only the zeros and the second part containing only the poles. And here we are giving the system function as h of z equal to h1 of z into h2 of z, where h1 of z is summation n equal to 0 to m minus 1 bk into z bar minus k, and h2 of z is given by 1 by 1 plus summation of k equal 1 to n minus 1 ak into z bar minus k, and this equation can be written by using h1 of z and h2 of z by using an intermediate function w of z. And here in this time domain this can be given by this equation. Now we can realize these two equations of h1 of z and h2 of z using basic building blocks and connecting them in cascade, and therefore we are obtaining the direct form structure. Here these are all the zeros and these are all the poles. Since here we are since in the direct form 1 realization we are giving the input and finally we are getting the output, and here first we are getting the delay element, and in the center part we are having the summers. Therefore first we are realizing the zeros and next we are realizing the poles, and finally we are connecting this to finally we are getting the direct form 1 realization. And these are the questions. Thank you.